Hello everybody, today I'm going to be going over momentum and impulse. So first of all, let's define what momentum is. So momentum can be defined as mass times velocity. And it's typically represented in the letter P. So the formula for momentum is P equals mv, meaning that the more mass an object has, the more momentum it will have, and the same idea for if the object has more velocity. The unit for momentum is kilograms times meters per second. Momentum is a vector, so that means the direction of the momentum actually matters. So let's say you have an object going right, and then it hits a wall. So it'll have a momentum going right, and then it'll bounce back and go the other way, meaning that it'll have two different momentums in two different directions. So using this simple formula, we can do some basic calculations. So the first one, we can get a 5 kilogram object. So let's say it's a ball, 5 kilograms, and it's moving at 10 meters per second. Using the formula, you can easily calculate this by just doing P equals mv, use brackets when substituting in, so 5 kilograms times 10 meters per second, and you get P equals 50, kilograms times meters per second. So let's do another question. So let's say a 0.5 kg object is moving at a speed of 7 meters per second. And then once it goes in the right direction and it hits a wall, after it hits the wall, it goes in the other direction at a speed of 3 meters per second. So I want you to calculate the momentum before it hit the wall and the momentum after it hit the wall. And after, I want you to calculate the change in momentum that it experienced. So you can take a time to pause the video and do this yourself, and then I'll just continue on. So to calculate the momentums before and after, it's simply the same formula. P equals mv, P equals 0.5 times 7. And you're left with P equals 3.5 kg times meters per second. So that's for the first one. For the second one, we do the same thing. P equals mv, and you go P equals 0.5 because the mass has not changed, but the velocity has changed, so we change that to 3 meters per second. And simply we're left with P equals 1.5 kg times meters per second. Now to find the change in velocity, we have to subtract the final velocity from the initial velocity. And keep in mind that these velocities or these momentums are in different directions. This one is going right, and this one is going left. So you want to find out what the total change in velocity was. So you take the final velocity, or not the change in velocity, change in momentum, sorry. So you take the final momentum, which was 1.5, and you subtract it from the initial momentum, which was 3.5. And you're left with a change in momentum of -2 kilograms times meters per second. So what you just did here was actually calculate the impulse. Impulse can be defined as the change in momentum. Change in momentum. It can also be defined as the force times the change in time. So let's say, let's use the same question. You have the ball 0.5 kg, moving at a speed of 7 meters per second. And it hits the wall. You can also define impulse as, or you can calculate impulse by finding the force that the wall exerts onto the ball when it hits it, multiplied by how long the ball was touching the wall. So let's say it was touching the ball for 0.2 seconds. You would have to multiply the force the wall exerts on the ball times 0.2 seconds to find the impulse. That being said, there are a few different formulas for impulse. So you can use the one that we did before, which was the final momentum subtracted from the initial momentum. An impulse, since it's a change in momentum, is typically written as like that, change in momentum. So it could be written as P final minus momentum initial. Or if you want to use the other one, the force times the time, it's the change in time. You can go change in momentum is equal to force times the change in time. Now, typically, it's just the total time, but if you're using a set time within, then you want to use the final time subtracted by the initial time. So with this, we can conclude that these two actually equal the same thing. So the final momentum subtracted by the initial momentum is equal to the force times the change in time. You can use either of these to double check depending on what they ask or how they ask you to solve the equation. You can use the other way to double check to see if your answer is correct. And you could also rearrange some of these. So if you want to find the force, you can do the change in momentum over the change in time. Keep in mind that to find the force, you might need to use formulas that you learned before, such as the F equals ma. Same thing if you want to find the velocity. If it doesn't give you the velocity, you might need to use other formulas. And one thing I want to quickly gloss over before we end this video is just that momentum is always conserved. This will be useful in our next video where we talk about collisions and different kinds of collisions and how they work and how they interact with each other. You want to know that the total momentum before the collision is equal to the total momentum after the collision. So let's write that down. Total momentum before is equal to the total momentum after. This is a really important concept to understand for the next video and the next few questions that I'll be going over with you. So that about wraps it up. I know it was a short video, it's a really simple introduction, but these are you just want to get these formulas down and then be comfortable with them because they're going to be useful in the next few lessons. So, thank you.